All right, so slope, when we're talking about slope, we're talking about the ratio. Is this running out? That's running out. It's the ratio of rise over run. The ratio of rise over run. And remember, again, I said slope is the same thing as constant rate of change. So it's also known as your constant rate of change. So the change of the y's over the change of the x. So that's what we mean when we say rise. The values that rise are your y values. So to be able to identify the rise, that's your change of y. Your change of your y values. And when we talk about the run, that's the x. So it's the change of your x values. Your rise is the change of the y's, your x is the change of, or the run is the change of the x. Okay, so the idea, again, constant rate of change, or slope, it's just your rise over your run. And when we talk about it, what's really important is that slope is presented in fraction form. So improper fractions is perfectly fine, because again, it's a rise over a run. There's no mixed numbers. You do not have a value in front of it. It is the rise. Sometimes the rise might be greater than the run, sometimes it might be less than the run. But it's rise over run. No mixed numbers. If they happen to give you it in decimal form, you just change your decimal into a fraction. And essentially, slope is just a direction, how to move from one point to the next. And when we're talking about slope, slope exists if it's a constant rate of change. It's what kind of function? Linear. That's right. It's a linear function. If a constant rate of change exists, it means there's a linear function. So slope is of straight lines. Now, it doesn't have to just be graphs of lines. Sometimes it might be actual situations that they're talking about. So, for example, a treadmill. Okay, so if you're in gym class and you're walking on the treadmill, so the treadmill extends 30 inches with an 18-inch incline, meaning it's raised to 18 inches. So I want to know, what is the slope? So essentially, I've got this little treadmill thing that's happening here. And it's like, you know, you got your little track, and it's raised 18 inches off of the ground with an extension of 30 inches. That's what it's meaning. So we want to know what the slope is, so we're trying to identify what the ramp is located like. So what's the rise value? 18. There's your rise. And then our run is the 30. Now, like always, it's a fraction. You have to what? Simplify. Okay, so both values happen to be divisible by what? 6, right? They're both divisible by 6. That's going to give you 3 over 5. So there's your slope. Okay, so if we have a hiking trail that rises 6 feet for every horizontal change, every horizontal change of 100 feet, I want to know what is the slope. Go ahead and identify the slope. All right, who can tell me what the slope is? Kendall? 3 over 50, very good. So we know that the rise happens to be that 6 feet, and that the run, that horizontal change, happens to be that 100. So we have 6 over 100 that has to be simplified. They're both divisible by 2, and that gives you 3 over 50. Okay, so I just passed out some graph paper for you guys, so that way you can put it on the next page. We're going to plot a couple of different lines, and you're going to identify the slope of them. Need one more? All right. Go ahead and get that copied onto your paper. And I'll let you know right now the points here, that's located at -2, -1. This point is located at 2, 2. And this point is 6, 5. So we're wanting to identify the slope. Does it matter which points I pick? No. It doesn't matter at all which points I happen to pick because slope is the same whether I go from the first point to the second, or from the second point to the third, or from the first to the third. Or even if I go backwards, if I go from the third to the second, or third to the first. It doesn't matter. The slope is the same no matter what. So all you have to do is identify the rise over the run. So I'm going to go ahead and do it from the first point to the second point. And I'm going to show you from the second point to the third point that they are still the same. So in order to get from the first point to the second point, what would my rise be? Jordan? 3, right? I'm going 1, 2, 3 units up, so it's a positive 3. Same thing if I'm going from the second point to the third point, it's still a 1, 2, 3. That happens to be a positive 3 for that as well. Then for the run, who can tell me what the run is going to be? 4, right? 1, 2, 3, 4. That's positive 4. Same thing here. 1, 2, 3, 4. A positive 4. So what's my slope? 3/4, right? 3 over 4. So it's a positive 3 over a positive 4. 3/4 happens to be my slope. All right, so given the following here, now again, when you're given lines, like for the first one I gave actual specific points, they're not going to do that. They're just going to have a line graph and you're going to have to identify where the points are. So who can raise their hand and tell me where's one of the points located at? Colin?
2 and 1.
A positive 2 and a negative 1? Right here? 1, negative 2. Okay, so there it is. We do have a point here at positive 1, negative 2. Where else? Arham? Okay, positive 2, negative 4. There happens to be another point. Good. Okay. So let's just focus on those 2 points then that you found. It's always easiest to find the points that cross over perfectly on the grids. So who can tell me what is the rise going to be? Jordan?
Okay, starting from 1 and -2, would it be plus, it would be -2, right?
Very good. It's a negative 2 because you're going downward. It's decreasing. right? So there has to be a negative in that situation. So it's a -2 for the rise. What about the run? What's the run? Positive or negative? Positive, because it's going to the right, right? So it's a +1. So a negative over a positive gives us what kind of slope? Negative over positive is a what? It's a negative. Negative over a positive is just a negative. So this is one of those negative slopes. So remember on the video, when he was going down on the slope, it was nice negative. When he was traveling upwards on the slope, it was a puff, puff positive, right? So real quickly, I'm just going to show you the reasons as to why the other two are considered to be 0 and undefined, which means you're going to need to have a use of your calculator. So example 5, I don't really need to make this a big graph, but my line, I'm just going to make it located. I'm going to go ahead and draw my line with a highlighter, a purple highlighter, or actually a pink highlighter. Okay, so there's my line in pink. So now, remember, our slope is supposed to be a rise over a run. And I can pick any points on here that I want. So I'm going to go ahead and pick a point right here at, -2, -2, and I'm going to pick it over here at positive, or I'm sorry, not -2, it's -2, +2, and at +1, +2. I'm going to pick those as my 2 points. So my rise, what is my rise? Huh? 0, right? To go from this point to this point, I don't have to rise up or down, so the rise here happens to be 0. And my run in this case happens to be 1, 2, 3. Well, now in your calculators, I want you to go ahead and type in 0 over 3. What's 0 over 3? 0. Okay, so when it's a horizontal line, it doesn't matter what you're going to do, you're always going to get 0 because the rise is 0. The run will be any number. But as long as the rise is 0, the whole thing is going to equate to a 0. Now this is, I ran out of room here, but I'm going to go ahead and move upward on mine. You probably have room still on yours somewhere, but go ahead and put in example 6 wherever you have room. So I'm going to put my example 6 over here. You don't need a whole lot of room for it, but now I'm going to graph a vertical line. And again, I'm going to pick any points that I want on that graph. So I'll pick a +1, +2, and a +1, +1. I'll just pick those 2 points. What's my rise? 1, right? But what's my run? Nothing, right? 0. Now go ahead and do 1 over 0. What do you get?
0.
Shh. Type it into your calculator. Show me what you get. Do 1 over 0. What does it show? An error. Okay, in your calculators it'll say error or syntax error because you cannot divide by 0. You can have 0 divided by a number and that will equal 0, but if you try to divide by a 0, it gives you an error because it doesn't exist. It's not allowed to. So that's why they call this type of slope undefined. Okay? It's an undefined slope. So those are the 4 types of slopes that we have. Yep. Shh. All right, your 4 types of slope. Your positive, your negative, zero, and then undefined. Okay, so now you know how to find slope with a graph. Let's go ahead and identify how to find slope with a table, which you, again, you know how to do it because you did it already with constant rate of change. If we have the x and a y table, and I have a table of 1, 12, 3, 9, 5, 6, 7, 3. Remember, the rise is also called the change of what?
X of y or x?
The change of the y is your rise. So this is where our rise is going to be located, is the change of the y. This is where our x, or our run, is going to be located, the change of the x. So who can tell me what's the rise in this situation? What pattern is occurring with our rise? Colin? -3, right? We're subtracting 3 every single time. What about the pattern for the run? What's the pattern of the run? +2. We're adding 2 every single time. So then my rise over my run is a -3 over a +2. So it's -3/2. Okay, what's the rise? Given this following table, what's the rise going to be? +1, right? My rise is happening with that y, and the y's are consistently increasing by 1. Well, this one's increasing by 2 here, but this one increases by 1. So you're going to have to check twice. You're going to have to check 2 of them. We have a change of a rise of 1 and a change that has a rise of a 2. You're going to need to make sure that they're the same in order to identify if there actually is a slope. What about the run? +4, and then +8, and then +4 again, right? So we have a +4 for the 1s and a +8 for that 2. Do they simplify to the same thing? Yeah, they are equal to each other. They both are going to be equal to 1/4. So then there's our slope, 1/4. Go ahead and find the slope for C. Colin? 0. Okay, because the rise has no change whatsoever. So it doesn't matter if it's always going to be 0 for our numerator, we know that it's going to have to be a 0 slope. Okay, the denominator, hey, it changes by 2, it changes by 5, it changes by 8, but 0 over 2 and 0 over 5 and 0 over 8, they all are going to be equal to 0 slope. So it's just a 0 slope. Okay, and the last little bit that I'm going to show you is the slope formula. And you'll have the slope formula on a reference sheet. It will be given to you on a reference sheet, but you still need to make sure you understand how to utilize it. And order does matter. When it comes to the slope formula, the order that you perform it does matter. Because if you perform it in the wrong order, it can mean that you would get a positive answer when it's supposed to be negative, or you get a negative answer when it's supposed to be positive. And having a positive versus a negative completely messes the problem up. Okay? So the order that you perform it is important. So given 2 points, if we have x1, y1, and we've got x2, y2, the formula is going to be y2 minus y1 over x2 minus x1. Now, these are not exponents. This is indicating that this is the first point and this is the second point. You're taking the difference from the second point to the first point. That's all you're doing. So you're subtracting your y's over the subtraction of your x. It's kind of similar to what you guys already did with the distance formula, but the thing with the distance formula, because once you subtracted, you then squared the value, it automatically always undid any negatives that you had. So the order really didn't matter when you were doing the distance formula, as long as it was the subtraction of the y's and the subtractions of the x's. But with slope, it does matter. If you subtract y2 minus y1, but then you do x1 minus x2, it's going to give you the wrong sign. So you have to be very careful. Whichever point you choose to make as your second point needs to stay the second point for both the y and the x. Okay? So if I've got the points 1, 2, and negative 4, 3, I have to label one of them as my x1, y1. So I'm just going to go ahead and label the first one, x1, y1. And I'm going to label the second point my x2, y2. And then I'm going to find the difference. So again, I'm doing y2, which is 3, minus y1, which is that 2, over x2, which is a negative 4, minus x1, which is a positive 1. Okay, so when I subtract them, what's 3 minus 2? 1. What's negative 4 minus 1? Negative 5. So my slope is a negative 1/5. Put your negative out in the front. Always put your negative out in the front. Because that means the negative can belong to either one of them. Which is true. Because I could have done 2 minus 3 and then 1 minus negative 4, and that would have given me a negative 1 over positive 5, which is still the same, still a negative 1/5. That negative can belong to either the numerator or the denominator, which means you can either do a rise of negative 1 or a run of negative 5. But you can't do them both negatives. It's only one or the other. And it's very important that you understand that that negative can go to either one of them, because eventually you're going to be using your slope to plot points to create a line, where they're going to indicate to you, hey, here's your y-intercept, and here's your slope, graph it. So you would plot your y-intercept, and then you use your slope as directions to where to plot the next 2 points. Okay? I want you to go ahead and find the slope for these next 2 problems. And be careful, because the number one mistake people make is that when they subtract negatives, they accidentally forget to put the minus sign. So be careful about that. All right, who can raise their hand and tell me what's the slope for problem 2? Joshua? Negative 2/3, correct. What about for problem 3? Lena? Anybody get anything different? Heaven? 1/2. Yeah. So 1/2. So let's take a look at those. So for the first one, if I label this as my x1 and my y1, and this is my x2 and my y2, When I subtract, I'm going to do 0 minus 2 over 5 minus 2. So 0 minus 2 is going to give me a negative 2. 5 minus 2 is going to give me a positive 3, so it's negative 2/3. Okay, for number 3, this is my x1, y1. This is my x2, y2. Now this is where I said a lot of people make mistakes is when they're subtracting the negatives. So sometimes it helps if you just set the fraction up and automatically write your minus signs. And then you just fill in the numbers. y2 minus y1 means you're going to be doing a negative 2 minus a negative 4. So it's negative 2 minus negative 4. And then it's a negative 3 minus a negative 7. A lot of people wind up just writing negative 2 minus 4 and negative 3 minus 7 instead of writing it as a minus negative 7 or a minus negative 4. And that causes mistakes. So negative 2 minus negative 4 is actually going to give you a positive 2. Negative 3 minus a negative 7 is going to give you a positive 4, and that would simplify to 1 over 2. If you forgot to write it as minus a negative, then you would have wound up having a negative 6 over a negative 10, which would simplify to 3/5. So you have to be very careful about that. It's minus a negative, not just minus 4, okay? All right, so your assignment tonight, or today, yeah, I'd stick it in there. Your assignment for today, you've got a worksheet, it's 24 problems, and it's just identifying the slope, either the type or solving, using graphs, tables, and points.